In lesson 2.3, we're going to start looking at polynomials. And as part of that, we'll actually define what a polynomial is and a couple other vocab terms that will be useful to us. But first, we're going to start with just looking at a few expressions, and we're going to pick out which one doesn't belong. Now, we've done this before in class, and you probably remember that there's an argument that can be made for each of these and why it doesn't belong. So we'll kind of run through that right now. When I look at this first one, as far as what makes it different than the rest of them, it seems to be the only one that is not in order. Right? All the rest of them start with the biggest exponent, and they go down from there. So this one, why does it not belong? Well, it looks like it's not in order. If we look at option B, well, let's see. Nothing crazy going on here, except one thing I'm noticing is that all of these, right, A, C, and D, their biggest exponent x term has just an invisible 1 in front of it, whereas this right here has the 2. So maybe that's one thing making it different. Option C, why is this one different? Well, this one looks weird because I've got right here an exponent that is not a whole number. This exponent is actually a fraction. And then option D, well, what's going on weird here? Let's see, we have some decimal numbers. Oh, but there's also a decimal here, 5.7, so that's not it. Let's see, what looks different? Oh, this one has no number at the end, right? Or if we think about it, the invisible number that we are adding or subtracting at the end here is a 0. So our constant term is just 0 in this problem. Now, moving on from there to a little bit of vocab. Polynomial is what we're going to be talking about a lot in this unit. And we're going to define polynomial here as a sum or difference. In other words, we're adding or subtracting. A sum or difference of terms where each term is a constant number times a whole number power of x. So what does that mean? So first of all, we're adding or subtracting a bunch of these terms together. So term is just a word for things actually that are being added or subtracted together. But what do each of those terms have to look like? Well, they are a number times x, where that x is being raised to a whole number power. That is really the important part here. So that means if we look back up here, option C is actually not a polynomial. And the reason is that 1/3 right there. All of the rest of these, if we look at them, whole number, whole number, whole number, whole number. Invisible number here is actually x to the 1. That's a whole number. Even the number just 2, we can think of this as times x to the 0th, because there is no x there. So all of these have whole number powers on their x's except for C. C is not a polynomial. Degree. We've talked about this term before, but we'll define it again here. The degree is just the exponent. Sorry, let me back up a step. The highest exponent in the polynomial. That's the easiest way to think about it. So if I look back at any of these problems up here, on B, for example, the degree would be 4, because we have that exponent 4. If I look at A, the degree would be 3. If I look at D, the degree is 5. And we can say it a couple different ways. We can say it is either degree 5 or we can call it a fifth degree polynomial. And then relative maximum or minimum, this one is going to talk more about graphs actually, but we will be looking at graphs in this lesson, so it's good to bring up now. A relative maximum or minimum. Relative just means that it's a max or min compared to the values that are around it. So a relative max or min is a value that is greater or less than, for minimum, all other values around it. Now the easy way to think about this is that a relative max, I'm going to draw a quick graph here. A relative max could be anything on top of a hill. So this is a relative max, this is a relative max. Whereas if we look down here, anything at the bottom of a valley, this is a relative minimum. So that's how we define relative max and relative min.